Okay, so let's list all the polynomials. So the names of them are called linear, quadratic, cubic, and quartic. Those are the names in your calculator. Remember on that list? So there was this one, linear, quad, cubic, quartic. Okay? So in that menu, okay? Those were the names of them. So linear would just be ax plus b. Quadratic is ax squared. So that one has just an x in it. That one has an x squared. Can you follow the pattern? So this one will have a ax cubed, bx squared, cx plus d. So those are all the main things you're looking for. You're looking for the biggest. And then finally a quartic has a 4th degree. Just the alphabet. DX and E. A, B, C, D, E. I ran out of room.
Is it letter D?
It goes A, B, C, D, E. And then your X's are going X4, X3, X2, X, and then no X's. I don't really know if you had a lot of problems, but it's in your calculator. It's just doing all the same steps in your calculator, basically, right? Just depending on what the question asks. If they tell you to do quartic, you just do the quartic. Okay, if the x is plus, if the x is minus, I'm trying to draw this like small so that we can fit lots of info on your sheet. Quadratic, what does it look like if it's a plus x squared versus a minus x squared? Do you know the shape? That was a U. Remember that? Flipped down. And then the positive x cubed, what kind of letter? It was a letter of the alphabet. Remember that one? An N. That was what a cubic looked like. A negative cubic. A positive quartic or negative quartic. So those ones were letters of the alphabet as well. So that was a W. Okay, so those are the general shapes. Okay, we'll just do all the functions, and then you'll probably also want to write some calculator notes down, right? Some cheat sheet notes about your calculator. Okay, so then we learned exponential. Okay, so this is y equals a times b to the x. Where b is your base. And And this was the general shape of an exponential. If base was bigger than 1, remember that? If you're growing, if you're exponentially growing, your rate is bigger than 1. What if you're exponentially decreasing? If base is less than 1. I feel like on these ones we did a little bit of work with domain and range. So the domain is all the x's, which is anything. You can write it either way. I don't care which method you write. How do you write the range though? The range is restricted. It'd be the lowest height of 0, and then it would go up. You can't be at 0. It'll never hit 0 though, right? It'll never, ever, ever hit 0. And if there is a coefficient in the front of that, it changes the y-intercept. So if you had any number, it would change the y-intercept. What is the regular y-intercept? Do you remember that number? It would normally have 1. Because think about exponentially, any exponent to a 0 power is 1. Okay, so that's why that point is there, but if you have something in front, it would change that point. Okay, then we had logarithmic, or in your calculator it only did the ln, the natural log. So the general shape of that would be the general shape of a logarithmic pattern. So do you remember what the properties were of a log versus an exponential? So this is the point 0, 1. This is the point 1, 0. Do you notice the range of this is the domain of this? And the domain is the range. So they get switched. You can write whatever you want, but I'm just trying to show you to understand the domain of this is the range of that, the range is the domain. Okay, they switch. So that was another function that we learned. Okay, then we learned sinusoidal. Okay, so this is a sinusoidal curve. Let me see here. So this is kind of the shape. Remember, the pattern of it was always alternating between a midline. So this one's midline, low, mid, high, mid, low, mid, high. It keeps going like that, right? Okay, so what do we all know? We know that the midline is y equals 3. So I do know that my equation would have a plus 3 at the end of it. Then we talked about the spacing from the middle to the up or the middle to the high, which is called the amplitude. So if I labeled my axis 1, 2, 3, 4, 5, then going through those 4 points, when you get to the 5th point, so going from a low back to another low, that completes a cycle, which is called your period, which is 4, because I went from 1 to 5. So it's a distance of 4. So that's a period, so you probably want to label a period on there. And you better put this on there. 2 pi over b equals period. Okay, so the b helps us figure out the period. So 2 pi over b, have that little formula on your sheet somewhere so you can use that. Because sometimes, remember, I asked questions about how long did it take the Ferris wheel to go all the way around, or how long did it take the stone in the bike tire to go all the way around. You just do 2 pi over b. Okay, I think, anything else you guys can think of? The C is the horizontal shift, and we didn't even talk about that, so that's why I'm not explaining it. Yeah.
Period 4?
The period is how long it takes you to make your way through a complete cycle. So pretend this was a pebble getting stuck, right? And then it went around, and then it made its way back around the whole circle.
Why is it 43?
Why is it 4? Because this one started at 1 second and it ended at 5 seconds. So how long did that take? So it's like a distance. It's not the x value of 5, it's the distance from that to that. Okay. The calculator, we just dealt with sine. Ooh, you know what we should write on our cheat sheet? Your mode. Everybody needs to make sure when you're doing this, that in your mode, your calculator graphs with radians unless your equation says something like 90 or 45. Okay, then it would be a degree equation. So if you're in radians, your x-axis, you probably want something like negative 2 pi to 2 pi. versus if you need to be in degrees, you would go negative 360 to 360, right? I would do a scale of 90. I would do a scale of pi over 2. I guess in that unit 2, we also kind of understood what was going on with degrees and radians. This seems like a really long time ago, doesn't it? Degrees and radians, do you remember if you were in radians, you would times it by 180, divide it by pi to get it to degrees? And then can you flip that around? If you were in degrees, remember that one too? The conversions? I guess we'll have to get into some of these questions to think about what else we need to add. Calculator stuff. I'm not sure what we all want to put on there. Do you remember how to do all this stuff? Okay, let's jump into some questions and keep that handy. I think we're going to do some calculator steps on this sheet as well. Okay, what page are we on here? Okay, choose the best estimate for 120 degrees. So I want to get it into radians. Did we write something on our cheat sheet that helps us? So on my exam, can I look on my cheat sheet and find something? I would times by pi and divide by 180. So I got 2.09 in my calculator. Okay, how are you going to do number 2? What's the best? You might think about, kind of know how many degrees that is, and then maybe you want to convert. Or some of you might know that pi is 180 degrees. So it's bigger than 3.14, right? Okay, what's your way? Maybe somebody probably wants to say, I know how many degrees that would be, right? How many degrees do you think that is? It's bigger than 180, and it's less than 270, right? What do you want to go with? 200 and how many? 240? Because this would be 180 and this would be 270, right? I would say it's closer to 270 than 180. Times pi over 180 then, because we wrote that on our cheat sheet. So that would give me pretty close to 4.2. Determine if this is an exponential function. So as we move, what does an exponential function do? What should an exponential function do? It should be timesing by the same. So here to here was I times by 10, times by 10, times by 10, and then here to here it gets times by 2. So an exponential always has to, so for instance, if your population is doubling, it has to double, and then the next day double. So 2, and then 4, and then 8, and then 16, 32. It has to keep doing the same pattern, okay? What is the y-intercept of this equation on the graph? What would the y-intercept be? Think about if x was 0, what would happen to the number? If x is 0, what's something to a 0? 1 times 5? Okay, and I put that on your cheat sheet, right? I said, right here, the number in the front changes your y-intercept. We wrote that on our cheat sheet. So there it is, right there. That would changes the y-intercept. Increasing or decreasing and why? What do you think? Did you think decreasing? And the reason? The base is less than 1. So if my population is 2/3 of what it is tomorrow, it's going down. Okay, so we have an equation, so we can go right into our calculator and put this in. So y equals okay, I already know my y-intercept is 120, and I also should already know that it's increasing because this is 1.15. That's an increasing rate. So I should go to my window, my y, I'm going to make, well, if it's a 120 and then increasing, what do you want to do? 400 for now? Okay, you could be doing this as a few times, right? You're just going to try something and change it if you need to. Okay, so my predictions were right. I can see on a trace that my y-intercept is 120 and we're increasing. Okay, we have the y is the number of bees. And the x is the number of days from now, right? Instead of having an n and a d, this is the y and this is the x. How many bees should the beekeeper expect after a week? Be careful because we were talking days and now weeks. So make sure you're in the right conversions here. So I want 7 days, right? Now, you have two options. Is this just trace, or is this the y2? Do I have an x, or do I have a y? This is just an x, so I just go trace 7. So this one on your exam, I would expect you can write this as a whole number, right? Some places you're going to be rounding to 2 decimals, but if it's a B, just do it to a whole number. Okay.
What did you resend?
Zoom 6 is just the 10 by 10.
If it's like 319.20, wouldn't you round up because you have like 23.2 out of
If you had 319 point what?
the 0.20, like you just round down? I would thought that you'd always round up.
Uh,
Same thing with people. Like,
No,
you have, like,
you would round just to whatever it's closer to. So you round down. That's only when you do the money payment thing where you no matter what round up. Because you always have to make a last payment. Okay. Cheat sheet. This is what I'm going to write because I saw something that was new. If I'm given X and want the Y, I'm going to hit trace number. What about if this is vice versa? If I was given a Y and I want the X, what do we do? So what's the other situation? Sometimes I give you the Y that I want. Then I do a Y2 equals, and then I do a intersection. Okay? I'd probably put that on my cheat sheet if I needed my strategies for the calculator stuff. Okay, determine the midline. So I can see that the top is 12 clearly and the bottom is -4. What number is in the middle? Might be a little bit harder to see on the graph specifically, but so I'm using the top and the bottom to think about what's in the middle. Do you have a number? It's halfway between there. What can you do mathematically? Add and divide by 2, right? An average. Okay, and if it's a midline, I would write y equals 4 is in the middle. Okay, determine the amplitude. So again, I'm just quickly going to write, hey, I can see the top is 8 and the bottom is -2. So the amplitude would be what? So what do you want to do? Do you want to say how much space is there between -2 and 8? How much space is in that zone? On a thermometer, how many degrees would you go up in temperature? 10? So each one would be five. A space of 5 and a space of 5. Or some of you might have wrote the middle was 3. Maybe you did that first and then figured it out. But I might only give you a range and then ask you what the middle is and things like that. So you have to be able to kind of play around with those numbers. Okay, determine the period of the following. So first of all, this scale, can you see that I think every tick mark is 60? So can you get me, we'll go from I'm just going to pick two of the same points. So I'm going to go from this top point to the next top point. You can pick this bottom and this bottom. You can pick whatever you want as long as it's the same point to the next repeating point. So the number on this was 600. What is the number on this one? If it's going up by 60s, then this should be at 300. So if it went from 300 to 600, how much distance, how much space is that? So the period equals 300 degrees. So the range, how do you write a range? It goes from low to high, and I'm going to write them with square brackets because it will get exactly to some low point to exactly a high point. So -6 is the bottom height, and 4 is the top height. Okay? Okay, a sinusoidal graph has a maximum point and the height is 3. I'm just marking the heights down because it's talking about amplitude. Amplitude is only the height. Then it tells me the midline is at -12. So what is the amplitude? How much space is there between those two numbers? On a thermometer, how much degree difference is that? Do we do 15? Okay, a sinusoidal graph has an amplitude of 9 and a midline at -2. So this is kind of my thought process. So I need to go above that by 9 and below that by 9. Does that make sense? So the range should be, what's the lowest? -2, and then if you go down 9. And FYI, your range should be 18 apart from each other. Those numbers should be 18 apart. If your amplitude is 9, the whole span should be 18. Okay, determine the amplitude of this one. So what am I looking at for amplitude? 2/5. That's it. If you forgot and then you wanted to graph it, what mode would you want to be in? What mode would you need to graph this in? Looking at the parts of the equation, this has a pi, so you would want to be in radian mode, and then you can look at the y values, but hopefully you just remember that that's it. what do I look at for the midline here? Which one is the midline? 2, so I'm going to go y equals 2 as an equation, because midlines. If I forgot, and then I went to graph it, what mode would you want this one in? Degree mode. If you needed to graph it, you would need to switch your mode to a degree mode. Okay, determine the period of the following. So what do we use? Which one? 5, 1.5, the 60, or the -5? Which one do we use for a period? We need the 2 pi over b. That's why you wrote that formula down. The period is 2 pi over b. Which one is the b value? The 1.5. So I got 4.19. If you forgot what to do, you can always graph it. What mode, again, would you need to look and say, what mode do I need to put in my calculator before I graph it? I would need this in degree mode, and then I could get an x value. I could get an x value. And then I could subtract those x values, right? If I forget, I could do something like that. Obviously, that would take a lot longer. Okay, determine the range. So again, I'm going to do this without graphing it. Why? How could I figure out the range? I need to understand the mid and the amplitude. I know the middle, and then I know the amplitude. So can you think about what that would do? If you're at -5 in the middle, you would need to go above it by 5 and below it by 5. Okay, the last looking sinusoidal question. Fill in the value. So can we label 5.5? Are we in agreement that that would look like the highest value? Then the 3 looks like a middle, then a low, middle, high, middle. So what's going on with the pattern? High, middle, low, high, middle, low. So I would need to fill in 0.5. Okay. So it looks like we did quite a good job of putting what we needed to here. We needed the midline. I don't know, we didn't write anything with range. If you needed to add something on your own with range on there. Okay. Polynomial function. So this is a cubic. What is the general shape of a cubic? General shape of a cubic. How many x-intercepts could you possibly have? It's not how many you have, so you can't just graph it and say this is exactly how many I have. How many could you possibly have? You could have 1, 2, or 3. You could have up to 3. You can't have 0, right? This is for sure going to cross somewhere. What is the y-intercept? How do we do the y-intercept like that quickly? If x equals 0, what happens? Gone, gone, -3. End behavior. Which quadrant is this to which quadrant is that? This is quadrant 3 into quadrant 1. And it'd be increasing. Okay, you'd have to look to see if it was a negative cubic, right? It'd be going from 2 to 4. Domain, this would go out both ways. Range, it goes forever up and down. And how many times could it turn? Do you know what I mean with a turn? It goes from increasing to decreasing. So that was a turn. And then it went from decreasing back to increasing. So it could have 2 turns. Turn around twice. What's that? Well, a quadratic would turn once, right? A line won't turn at all. It's always 1 less than the degree. Okay, identify the correct polynomial. So which function is this one called? Quadratic. I'm looking for something with a positive x squared in it. And I'm also looking for something, if I plugged in 0, it needs to get a 4 out. Those are the 2 things I'm looking for. Okay, now this is out. It's only an x. This one is out because it's just an x. The bottom 2 are out because they have x cubes in it. So that's a cubic, that's a cubic. Now, did this trick you? Does this make you think there's only x's in it? Or do you understand when you would multiply it, it would make a x squared, right? And guess what? This one is out because why? It has a negative x squared, so it's out. So it's that one, and if you really wanted to, you could also plug in 0. Does it come out to be 4? Yep. Okay, let's write it down, or we're gonna do this, and then we're gonna write some calculator instructions, stat edit stuff. Do you remember all that stuff? Stat edit, vars, all that. Okay, so maybe we'll start, and then we'll transfer what we're gonna do. Okay, steps. Stat edit. You got your L1 and L2, so up clear. Up, clear, down. We're good? Okay, ready. I'm going to go 60. I'm going to put all these into my x. Okay, what happened next after this? We had to hit the y equals button. I'm going to get stuff out of there. And then I'm going to go up here and I'm going to activate my plot. And then we did a zoom something. Do you remember the number on that one? Zoom 9 for statistics. Okay, if you looked at this, would you know what shape is it making? Is it making a U? Is it making a line? Is it making a U? Is it making an N? Is it making a W? It's making a line, but it also tells me this. Linear regression. So it's making a line. Okay, so we're going to go stat, calculate, down to number 4. Lin regression, enter, enter. Write your equation. You can go to 2 decimal places. Okay, so we put down X as the number of bikes. I might have, oh, this is kind of a weird problem. You might have done it differently. Because I don't know, does the number of bikes you have in the store depend on your floor space? Or does the floor space you need depend on the number of bikes? Okay, what do the slope and x-intercept represent? Okay, I'm going to skip that question because this is a very confusing problem. Okay, let's just do this one. Estimate the number of bikes. So estimate the number of bikes when you know this y. Okay, ready for more calculator stuff? Go to y equals. Hit vars, stats, to equation, regular equation, and it's in there. You can graph it to see if it matches your points. Go back, deactivate your plot. You don't want your plot on anymore, so you want those dots gone. Okay, now what do I do if I know the y and want the x? We wrote this one down. Y2 intersect. Y2 intersect. So y2 intersect. Yeah, I would do this to a whole number if it's bicycles. Yeah, I just rounded up because it was 0.55. All right, let's write this down. Okay, so when you're given a table and you need to get an equation, you're obviously going to have this on your exam somewhere. Okay, so we did stat, edit, L1, L2. then we hit y equals, and we activate plot 1. And then we did a zoom number 9. And then we hit the stat button. We went to calculate. You would have to pick your equation because it depends. If you had a quadratic, quartic, cubic, whatever, you'd have to pick it. And then hit enter, obviously. Okay, now you want to copy and paste it. So to copy and paste, we hit y equals, and then we hit vars, we hit number 5, statistics, equation, regular equation. And then you're going to have to always remember to deactivate the plot 1. After, when you want to get your stuff, you need to deactivate the plot because you're done with it at that point. Once you have your equation in there, then you're done with your points. Okay, should I call that good for today? That was a lot.